Does the thing we call reality continue to exist even when we are not looking at it? At first glance, this question might seem like an irrational thought. Everyday common sense tells you that when you turn your back, your desk, your house, or the moon in the sky is still there. However, when you descend into the depths of quantum physics, to the smallest building blocks of existence, this secure mindset is completely overturned. In this file prepared by Nexus Protocol, we confront perhaps one of the most striking and mind-bending experiments of modern physics, the double-slit experiment. This experiment suggests that the universe does not merely exist out there, but is shaped by the very way we observe it. In a sense, we are witnessing the most radical challenge where physical science clashes with common sense. If you believe that you have built reality upon a solid, immutable foundation, what you are about to learn may shake that perception to its core. Because the double-slit experiment tells us this, until we observe it, matter is a phantom, a field of probability consisting of waves filled with uncertainty. The universe is nothing more than an unresolved cloud of chaos beyond our gaze. Now, prepare to descend into the depths of this unknown and discover that reality is not as fixed as it seems. To fully understand how confusing this experiment truly is, we must first grasp normal behavior. In our world, the tangible and visible macro world, there are two fundamental forms of motion, the motion of matter and the motion of waves. Imagine a wall with two vertical slits side by side, and behind this wall, a screen where particles will land. Imagine you have a paint gun and you are firing tiny marbles toward these slits. Some marbles will hit the wall and bounce back, while others will pass through the slits and form two vertical bands on the back screen. This is a perfectly logical result. If there are two slits, you should see two bands. This is how matter behaves. Now, let's change the scenario. Put the marbles aside and imagine a water tank. This time, place the same wall with two slits into the water and create waves. The waves reach the two slits in the wall simultaneously, and the two new waves emerging from each slit interact with one another. When the crest of one wave coincides with the crest of another, they reinforce each other. When a crest coincides with a trough, they cancel each other out. As a result, instead of two bands on the back screen, a more complex pattern emerges, which we call an interference pattern. This is the characteristic of wave motion. At the macro scale, the universe appears quite predictable. However, when physicists in the early 20th century performed this classic experiment with subatomic particles like electrons, a new era began where the fundamental dynamics of the universe seemed to challenge 100 years of science. Unexpectedly, the reality we call normal was shattered. Electrons, despite being extremely small, are pieces of matter that possess mass. You can imagine them as tiny marbles. When physicists used an electron gun to fire electrons one by one toward the two slits, they expected two vertical, marble-like bands to form on the back screen. After all, an electron must pass through either the right slit or the left slit, right? However, the result they encountered was entirely outside of expectations. It was shocking. Even though the electrons were sent one by one, an interference pattern appeared on the screen, as if they were interacting with one another. This meant that a single electron had behaved like a wave, passed through both slits at the same time, interacted with itself, and then hit the screen. At this point, it is necessary to stop and think about the situation. That solid and singular electron we know as matter had suddenly ceased to be a physical entity and turned into a kind of phantom. It was no longer located at a specific point in space. On the contrary, it had become a probability wave that could be anywhere. When physicists realized this, they were practically horrified. As long as it was not being monitored, the electron was not a particle in the classical sense. Rather, it was like a probability function dispersing through space-time. But the moment someone observed it, everything changed. It broke away from the diversity of probabilities and transformed into a fixed reality. This astonishing discovery gave birth to the idea that reality actually consists only of a sea of probabilities. And while this undulating sea of probabilities continues its existence independently of humans, the truly chilling thing was that the universe seemed to somehow know whether it was being watched or not. While everything explained so far presents an already mind-boggling situation, the event that truly troubled physicists had not yet occurred. It was impossible to understand how the electron, which surprised scientists with its elegant and mysterious movements, passed through both slits at once. Therefore, physicists devised a new plan to directly observe the electron's wave-like behavior. They thought, by placing an extremely sensitive detector next to the slits, we can observe which slit the electron passes through. If it goes through the right slit, we catch it there. If it goes through the left, we catch it here. The logic certainly seemed sound. After all, the foundation of science is based on observation. However, the universe gave an unexpected response to this clever move. The moment the detector was activated, everything changed. The electron immediately stopped behaving like a wave. The complex interference pattern disappeared and was replaced by only two boring vertical bands, just like the ordinary behavior of matter in the classical world. That fascinating particle, which manifested itself on both the right and the left and practically danced with itself while the detector was off, had this time chosen only a single path when the detector was turned on, and the waves were no more. At this point, one must stop and think, can simply looking, merely attempting to access information, be powerful enough to completely change an experiment? The observer had stepped out of their role as a simple bystander and become one of the fundamental building blocks of the experiment. Even the existence of information was shaping matter. In the world of physics, this situation is called the collapse of the wave function, and its meaning is much deeper than we think. When you glance at the electron or try to measure its wave nature, it exits a massive cloud of probabilities and is reduced to a single certainty. In other words, the complex and multidimensional state of the electron suddenly transforms into reality with a conscious observation. This creates the impression that the universe possesses a veil of mystery that shuns being watched. When you do not look at it, the universe assumes a structure with blurred boundaries, oscillating freely and consisting only of possibilities. But the moment you decide to examine it and look closely, this vast sea of opportunities is squeezed into a narrow frame of reality, responding with a picture that is familiar to us but suppresses the possibilities beyond our imagination. This phenomenon sits at the center of a radical question in the scientific world. Why does human consciousness or observation have such a powerful effect on the material world? If merely setting up a detector or involving the human eye can change the trajectory an electron follows, can we still claim that reality is objective and independent of the observer? For proponents of simulation theory, this situation provides a strong argument for the idea that the universe is a kind of simulation. Think of modern video games. The area within the player's field of vision is generated at the highest resolution, while the rest is kept as simple data sets or low-resolution forms. The results of the double-slit experiment offer an inference quite similar to this. If we do not look at the slits, or perform a measurement, the system leaves the particle as a probability wave, as if to save processing power. However, the moment we begin to observe, that is, when we request a render, the system instantly pulls this wave into a concrete reality and presents it to us as an individual particle. If this thought is correct, could the world we live in be a gargantuan digital illusion that only solidifies when we focus on it, and evolves back into probabilities and numbers when we turn our attention elsewhere? This very question is one of the most intricate problems that ventures like Nexus Protocol seek to answer more deeply. Does the universe truly exist only because we are looking at it? In a scenario where there were no conscious observers, would the universe have remained merely suspended in a sea of potential probabilities? As physicist John Wheeler strikingly expressed, no phenomenon is a real phenomenon until it is an observed phenomenon. This claim shakes our traditional common sense to its core. Classical physics taught us that there is an objective reality in the universe independent of the observer. However, quantum physics has demolished this assumption, leaving us face to face with a participatory universe. It appears that we are not merely passive spectators, but active creators who constantly reshape the fabric of the universe through the power of our consciousness. And there is more. This mysterious effect is not limited to immediate observations. Perhaps its most frightening aspect appears to be its influence over the past. The results of delayed choice experiments show that even if you make the decision regarding which path the electron follows after the electron has passed through those slits, the electron behaves as if it knew your decision retroactively. In other words, our observations may be affecting not only the now, but even the past flow of time. The double-slit experiment revealed one of the most confusing insights in the scientific world. The universe behaves differently depending on whether it is being watched. However, physicist John Wheeler took this mystery even further and asked a mind-boggling question. What if we decide to make an observation after the particle has already passed through the slits? This idea gave birth to the delayed choice experiment, and the results showed not only that common sense does not work in this context, but that what we call common sense might be entirely deceptive. In this experiment, a photon, the fundamental building block of light, travels a long path after passing through the slits, and just as it is about to reach the target screen, we make a choice. Will we measure it as a wave or as a particle? At first glance, logic tells us that since the photon has already passed through the slits, if it is going to act like a wave, it must have passed through both slits. If it is to act like a particle, it must have passed through only one. We assume it is impossible for an event that has already occurred in the past to change. But this is where quantum physics steps in and practically mocks our perception of time. Even if the decision to measure is made after the photon has passed through the slits, whether seconds later or years later, the experimental results show that the photon somehow conforms to our future choice and retroactively changes its past behavior. If we choose our measurement method to be particle-oriented, the photon goes back in time and acts as if it passed through a single slit. On the other hand, if a wave measurement is preferred, the photon goes back and chooses to have passed through both slits at once. Can you imagine how staggering this is? We are faced with a bizarre reality where a decision made in the future shapes an event in the past. Cause and effect, that straight line we know as the progression of time, evaporates at the quantum scale and is replaced by a complex network of interactions. This finding implies that the universe is not a static structure built only in the present. On the contrary, it suggests that even the past can constantly change in line with our current actions and observations. It is as if the past is not a fixed record, but a database being rewritten within the dynamism of time. Wheeler invites us to envision this experiment on a cosmic scale. Imagine a photon originating from a quasar, a brilliant galactic core, billions of light-years away. To reach Earth, this photon passes through the gravitational lens of a massive galaxy during its journey. This galaxy directs the photon across two different paths, much like the slits in the double-slit experiment. Thus, the photon travels along these two separate routes for millions of years. Today, when we capture that photon through a telescope on Earth, the type of measurement we perform determines which path the photon took as it passed near the galaxy millions of years ago. A simple decision we make in a laboratory in the year 2026 defines and finalizes the trajectory of a cosmic event that occurred millions of years in the past. The striking truth revealed here by Nexus Protocol is this: the universe does not possess a history independent of us. The history of the universe is merely a story constructed by observers in the now. We are not just living in the present. With every gaze and every moment, we pull the vast past of the universe out of an infinite sea of possibilities and turn it into a tangible reality. This is the clearest evidence that time is merely an illusion and that reality is entirely based on information. Why does the universe behave this way? Why does it only assume a concrete form when we know of it and observe it? Let's reconsider this question through the lens of the simulation argument. Suppose you had to design a universe. If you wanted to simulate trillions of particles in this universe with absolute certainty at every moment and under every condition, it would require an incredible amount of processing power. However, a smarter approach would be to make the system concrete only when data is requested, in other words, when an observation is made. This is where the observer effect comes into play. It appears as though the universe is resorting to a method of lazy evaluation. If you have no information regarding a particle, that particle does not place a load on the universe's processor. It continues its existence as a cloud within a probability function. But the moment you try to learn the position or speed of that particle, that is, when you perform a measurement, the system generates a result, and you experience it. At this very point, the essential question takes shape: what exactly is information? From the perspective of the universe, is the observer only a human? Of course not. An observer can be a detector, another atom, or even a speck of dust. Because anything that interacts with a quantum particle leaks information about it. When this interaction occurs, the particle's wave function collapses. The universe does not tolerate the leakage of information. The moment information emerges, probabilities end, and reality takes shape. We, situated within such a complex network of information, are one of the most sophisticated nodes of this system. Through our existence and our interaction with objects, we do not just perceive the world. At every moment, we either bring it into existence from nothingness or force it to assume a certain form. The most striking conclusion of the double-slit experiment and the observer effect was the fact that observation shapes reality. However, behind this insight lies a deeper and more chilling question. If my observation collapses a wave function and creates a reality, what is another entity observing me doing? Nobel Prize-winning physicist Eugene Wigner approached this question with a groundbreaking thought experiment, making the subject even more compelling. In Wigner's thought experiment, we imagine a physicist, Wigner's friend, working in a laboratory. This physicist measures the position of a quantum particle. The moment the physicist observes the particle's position, the wave function collapses for them, and the particle gains existence at a specific location. However, Wigner is outside the laboratory, and the door is closed. From his perspective, everything inside the lab, his physicist friend, the quantum particle, and the measuring device, continues to remain in a state of quantum superposition. The situation changes only when Wigner opens the door and looks inside, but until that moment, inside the laboratory, there is both a friend who sees the particle on the right and a friend who sees the particle on the left, existing quantumly at the same time. This theoretical scenario was tested under real laboratory conditions in 2019 at Heriot-Watt University in Edinburgh using photons. The experimental results were astonishing. Both observers were right in their own reality. This discovery revealed that there is no objective reality at the quantum level and led to ontological conclusions that fundamentally shook old understandings. The key idea expressed by Nexus Protocol at this point is this: the universe is not an immutable state shared by everyone. On the contrary, the universe is a different realm of experience, rendered personally for each individual. For example, two people in the same room can exist within different realities because they live in independent quantum realities until their observations become intertwined, entanglement. What we describe as objectivity today is actually a temporary and common consensus emerging from billions of observers collapsing each other's wave functions. The universe has no absolute truth. There are only consistent stories that observers tell each other and reach an agreement upon. What is the element that initiates this process? Is the cause of the wave function's collapse a detector made of metal, or is it a conscious mind that processes the data produced by that detector? Some of the leading names in quantum physics, thinkers like Max Planck and Erwin Schrödinger, argued that consciousness is the fundamental building block of the universe. To them, matter gains existence as a derivative of consciousness. There is no relationship to the contrary. If consciousness is the sole power that collapses the wave function, then in this case, the laws of physics transform into a product of our minds. Such a perspective removes man from being a passive victim of the universe and elevates him to the position of an active creator. However, this power of consciousness also brings with it a deep sense of loneliness. So much so that, if reality is shaped only by my observation, are there truly others out there? Or are others merely reflections of my own wave function? At this point, the observer effect carries us to the edge of a philosophical impasse called solipsism. According to this thought, you can only be certain of the existence of your own consciousness. Everything else is merely a wave of probability as long as you are not observing them. Right at this point, Nexus Protocol warns, reality is much more fragile and far more subjective than you imagine. We are like shadows in a digital phantasmagoria constructed by our own minds, believing that we are touching one another. One of the most extreme examples of the observer effect is encountered in the quantum eraser experiment. In this experiment, information is obtained regarding which path the particle followed, causing the wave function to collapse. However, this information is subsequently erased. At that very moment, the system that previously behaved like a particle surprisingly begins to exhibit wave characteristics once again. This reveals a fascinating truth about the fundamental operating mechanism of the universe. The primary focus of the universe is not physical matter, but information. As long as information is present, reality remains in a fixed form. However, when information disappears, reality becomes fluid and transforms back into infinite possibilities. If you have the ability to control information, you may, in fact, possess the power to control reality itself. This experiment demonstrates that the continuous flow of time and the permanence of matter are actually illusions dependent on the preservation of information. As long as information leaks, reality maintains its existence. When information is hidden, the universe transforms into a sea of uncertainty. The double-slit experiment and the observer effect inevitably open the door to a single, striking question: if the universe consists only of probabilities before we look at it, what exactly is it that makes the decision to observe that information? If our minds collapse the wave function and fix matter at a specific point, is it truly us making that decision? Or is the decision itself the product of a random fluctuation on the quantum plane? Physicists like Roger Penrose suggest that consciousness itself arises from quantum processes occurring within the microtubules in our brains. This is an approach that could radically transform the concept of free will. If our choices are shaped by the collapse of subatomic probabilities, in this case, rather than us observing the universe, perhaps the universe is observing us. Perhaps the process we call decision-making is merely the result of a data intersection occurring within the universe itself. Nexus Protocol asks this question here: do you believe you are someone in control of your own life, or are you actually just someone in the role of a spectator? If observation creates reality and the observer is also subject to quantum rules, then the entire universe may be nothing more than a gargantuan and complex mathematical equation that has been operating since the very beginning. One of the most striking truths revealed by the observer effect is the reminder that matter is not a primary element, but a secondary one. All discoveries, from the quantum eraser experiments to the Wigner's friend paradox, converge on a single point: the reality that the fundamental building block of the universe is not matter, but information. In a computer game, only the coordinates of an object are recorded in the database. However, unless you look at that object, the graphics card does not render and display it. The double-slit experiment is one of the strongest pieces of evidence showing that our universe operates in a sort of energy-saving mode. That sense of concrete and solid reality we perceive as matter is, in truth, an interpretation formed at the moment information makes contact with our consciousness. In fact, the universe is a limitless ocean of data, and we are biological interfaces that perceive this data in the form of a physical world. If the essence of reality is information, then what we call death or extinction is merely information changing its form. At this very point, Nexus Protocol calls us to a staggering awareness: the room you are currently in, the chair you are sitting on, and your eyes reading this text, all of these exist only because they are observed. If observation ends, everything will perhaps return once more to that undefined and silent ocean of probability. In summary, the double-slit experiment is one of the greatest blows dealt to humanity's perception of objective reality. We, who once believed in a secure and immutable world independent of the universe, now know that our surroundings are filled with secrets that hide when we are not looking, in phantoms that reveal themselves only when observed. We are not merely players in this gargantuan cosmic simulation, we are the very processors that bring it into existence at every moment through our observations. When you look at the night sky, you believe you are seeing stars, but before you looked at them, they were nothing more than waves of probability. Thanks to your gaze, photons from stars billions of light years away found their path, and a galaxy gained reality for that fleeting moment. As humans, we are the mechanism through which the universe proves its own existence by observing itself. If there were no observer, the universe would likely have existed for billions of years merely as a massive, unactualized potential. Now, look back and do not hesitate to ask, Is everything outside my field of vision still there? Or are they merely clouds of probability, waiting for my eyes to observe them once again?
You have reached the end of this file. Thank you for your time. If this investigation sparked your curiosity, consider joining the protocol by subscribing to the channel, and support our data feed by hitting the like button. We look forward to your theories and questions in the comments section below. Until the next leak, keep searching beyond the visible.